here we go, here we go. Here we go, here we go.
Welcome back to AWS What's Next. I'm Nathan Peck. I'll be your host for this next segment. And today I'm joined by Efe Karakus from the ECS Developer Experience team.
So hello, everyone.
Today we're going to be talking about a recent launch called AWS Copilot. And if I understand correctly, this is an open source project which was released on GitHub a few weeks ago. And it's already accumulated over 760 stars. So what exactly is this that folks are so excited about?
Sure, yeah. So AWS Copilot is a new command line tool to help customers build, release, and operate containerized applications on AWS. We launched it on July 9th at the AWS Cloud Container Conference. It's, like you said, it's developed by the Amazon ECS Developer Experience team. It's completely open source. You can find it on GitHub at github.com/AWS/copilot-CLI. Please give us any feedback, feature requests, any issues that you might come across. We'd love to hear from you.
Awesome. So first of all, congrats on the launch. Now let's go through a few terms. You mentioned a few things. I want to make sure everybody in Twitch chat and listening in, maybe on LinkedIn or wherever else we're streaming, understands the terminology we're talking about. So you talked about command line app. Obviously, there's different types of applications that you might run. What exactly is command line in this case?
So by command line, we mean this just like a tool. If you're familiar with the AWS CLI, for example, it's just like the AWS CLI. You would use Copilot on your terminal.
Okay, so I'm not going to be using this on the web console. I'm going to go to my terminal. And then you mentioned containerized application. What is this container we're talking about? We're not talking about a box here, but what is the container?
Sure, yeah. So like you said, the containerized application, it really has two terms, right? Container and application. And by container, what we mean is a technology that allows developers to take their code, their runtime engine, for example, Node.js, any dependencies that they might have, and package them up into a container image. Then this container image can be run on any machine that's running Docker. So it's a super easy way of making sure that your software can run really on any machine.
That's awesome. Yeah, I know in the past working at various startups and writing code, I often ran into issues where I wrote some code on my development laptop and then I handed it off to another developer and the code didn't run right, or we tried to deploy it to a server in the cloud and it didn't run. And so we had to figure out, okay, well, how are we going to get our code to run reliably in every location that we want to run it? And containers was a solution that we came upon specifically because of what you said, which is that it allows you to package up all those applications of the code I'm writing, the program I'm using, the runtime to actually execute my code, and any other libraries I need. So that's huge. So with Copilot, so we know what the containerized application is. What's the problem that Copilot is solving when it comes to actually deploying this containerized application in the cloud?
Sure. So first of all, Copilot provides an end-to-end experience for developers to both build as well as releasing, as well as operating your containerized applications on AWS. So when you think about the AWS landscape now, we have lots of great building blocks, right? We have the Amazon Elastic Container Registry to manage your container images. We have Amazon ECS, the Elastic Container Service for container orchestration to make sure that your containers are always up and running. You can do auto-scaling, lots of management stuff for your containers. And we have many options for databases, right? For example, Amazon DynamoDB. And developers right now, they have to do a lot of glue work, right? You need to figure out, how do I connect an ECR repository with my ECS service? How do I connect my ECS service with my database? It's not about just doing this like glue work. You want to do that with best practices in mind, right? You want to make sure it's like cost effective, it's reliable, it's secure. And Copilot takes that burden away from you. What we do is that we take as input a Docker file, and then you tell us what kind of architecture you want. For example, I want a load balance web service. I want to take this Docker file and just run it on AWS behind the load balancer. And Copilot will figure out all this glue work for you. It will provision the infrastructure with best practices in mind.
But that sounds amazing. I know every time I start a new application and I'm thinking about what architecture I want to deploy, I'm always worried about, did I accidentally leave a port open and like some hacker is going to get into my database? Did I accidentally get my permissions model right? And maybe somebody's going to be able to get into my S3 bucket. So having something there like Copilot to help me design things properly and make sure I have my settings correct. That sounds amazing.
Mhm.
Huh.
Yeah.
So tell me a little bit about what happens next. So I use Copilot to deploy the application. Um, Once it's deployed, what else can Copilot do for me?
Yeah. So, by providing an end-to-end experience would mean exactly like you said, your application, as an application developer, you don't stop at just like building and modeling your infrastructure.
Mhm.
Then afterwards, the service is up and running and you need to troubleshoot if a problem occurs, right? So Copilot is also there for your operational commands. So you don't have to context switch to a different tool. You can do both your infrastructure provisioning as well as operating your service through the same CLI, through the same tool. So you
That's
would do,
awesome.
for example, like Copilot service status or Copilot service logs to be able to view the health of your service or to be able to view the logs for your service.
So what does Copilot do that's different from other infrastructure provisioning tools? Because I've used different tools to deploy. I've
Yeah.
sometimes I go into the console, AWS console directly to build out my application. I've used like Terraform, CloudFormation directly.
Yeah.
How does Copilot compare to those experiences?
Yeah, great question. I mean, like you said, we have so many tools out there, right, to be able to do infrastructure provisioning. But Copilot is not just an infrastructure provisioning tool. Just like we were saying earlier, it also allows you to operate your service. So you could do like service status, service logs. But in terms of just infrastructure provisioning, Copilot under the hood uses CloudFormation. But if you were to use AWS CloudFormation directly, you will be starting at a blank template. So you would have to define every single infrastructure resource yourself. Instead, with Copilot, you just get these pre-populated templates, right? Because as an input, you tell us, hey, I just want something behind a load balancer, or I want a service that's private that only other services in my application might want to access. And then we'll like populate the template with best practices in mind. When we compare it against the AWS Cloud Development Kit, the CDK, CDK is also an abstraction on top of CloudFormation. But instead of defining your infrastructure resources in YAML, you would write in your preferred programming language, such as Python or TypeScript. But with Copilot, one of our differences is that we can provide deep integrations between your ECS services. For example, if I want to add multiple services that are behind the load balancer, I can, with Copilot, that will automatically get added, under the same load balancer. But if you were using CloudFormation or the CDK, you will need to think a little bit deeply about, I need to take this load balancer, place it in a separate CloudFormation stack, then take my services and place it under a different CloudFormation stack, make sure that they are wired up together sensibly. Copilot abstracts that away from you. We also recently announced an integration between Docker and ECS. And that's a great starting point if you're using Docker Compose. If you're really well familiar with Docker Compose, it really eases your life with getting started with ECS. But with Copilot, we provide some deep integrations between other AWS services. For example, we provide nice way of integrating with DynamoDB or an S3 bucket. We can also set up an AWS code pipeline for you.
Wow. So for those who may be familiar with how we build services and offer new features at AWS, one of the things that we do before we actually define anything, before we start writing any code at all, is we like to create a set of tenets. So I want to ask, with Copilot, what are these tenets or principles that are guiding how Copilot was built and how the experience was designed for these end users of Copilot?
Yeah. So as we said earlier, Copilot is open source. You can find it on GitHub. And in the repository, we have a file there named Charter. That's where you can view our design tenets if you're curious. The first design tenet that we have for the CLI is that users think in terms of architecture and not of infrastructure. For example, developers that want to create a new microservice, they shouldn't really have to think about all the networking configuration. You might not even know what's a VPC, subnet security groups, load balancer settings, or complex pipeline configurations. Instead, as developers, when we're building a new application, we really like to think in terms of black boxes, right? Like we'll say, okay, I want a microservice that's fronted by a load balancer, and that will connect to a database, right?
Yeah, usually
And that's
when I'm designing a new application, the first thing I do is I go on that whiteboard and I put like a little box and I put like an arrow over to another box. You know, I'm not actually thinking about like the rules and like lower line
exactly.
configuration. I just think about this box connects to that box connects to that.
Yeah, you don't think about the target group of how I'm going to configure that, right? So that's exactly the type of input that we want to take with the CLI. With Copilot, you provide your Docker file so that we can create a container image from it. And then the second input that you provide us is what kind of service you want in your application. So if it's a load balance web service, we'll put that behind a load balancer. Or if it's a backend service, then it's going to be not public, so nobody from the internet will be able to access it, but your other services will be able to access it. The second design tenet that we have with the CLI is creating modern applications by default. And by modern applications, what we mean is really, just like what you described earlier with the microservices and lightboxes, is that you typically tend to have more than one microservice in your application. So you'll have multiple microservices. You might have some jobs. You might have some supporting resources like databases. And with the CLI, we ensure that all parts of your application are wired together securely and sensibly. So this is my favorite tenet of the CLI, because what you were saying earlier is that I don't want to have to think about how to create the roles to be able to really access this database, right? So for example, when you run Copilot storage in it, we'll create either a DynamoDB table or an S3 bucket, and we'll automatically add permission for your ECS service to be able to read and write from that database, as well as inject any environment variables that are needed for you to be able, from your source code itself, to be able to access the database, right? So we can provide this sort of deep integrations between other AWS services with your containerized service. Our third tenet is delivering applications continuously. So while the AWS Copilot CLI can be used to manually deploy changes, so I can type Copilot deploy and it will just deploy to the environment, we always help customers to move to a continuous integration and continuous delivery pipeline by managing, and setting up pipelines. So we all know as developers how important it is to set up continuous delivery pipelines. It results in increase of software throughput, better software quality, as well as like happier devs on your teams, right? You don't have to create approvals and like make sure you chase someone else, a manager, to get an approval for a deployment.
Yeah,
So
I remember some of the startups I worked at in the past. There was only one person who could do the deployment. Sometimes that was me. Sometimes it was someone else, and then they would go off on vacation for the week, and I'd be like, "What? What? We can't actually get any of our code onto servers right now because this person was the only one who had access to actually take the application that we had built and deploy it to the server." So that meant maybe there was a bug that would be impacting customers for a couple of days, and that's not ideal.
Yeah, we want to avoid that. We definitely don't want to be in that situation. So with Copilot, what you can do is that you can create multiple deployment environments very easily. You type Copilot nvinit, and you can say, hey, I want to create a test environment or a deployment environment. And each one of these environments can be in different AWS accounts or different regions. And then you type Copilot pipeline in it, saying that, hey, I want to wire now, my first stage in my deployment will be the test environment, then a production environment, and we'll release all your services automatically. So that will create an AWS pipeline for you. And you don't have to go and hack, any release scripts yourself or wait for someone else, to go and deploy your changes for you. And the last tenet that we have with the CLI is that operations is part of the workflow. So this is what we were trying to say earlier with the definition of what AWS Copilot does by providing an end-to-end experience. Provisioning, so far we've been talking about provisioning, modeling, resources, infrastructure resources, but that's not the end of the story. We want to be able to help you troubleshoot and debug when things go wrong. Right? So we provide commands to help monitor the health of your service as well as visualize the logs. I'm super curious what we can do there, right? Like if you have any ideas on how we could set up traces for you, maybe automatic metrics and alarms and dashboards, would love to hear from you. Just create an issue on GitHub for us, and we'd love to hear back.
That's awesome. I see a few questions in the chat I wanted to highlight. One question is there any way to import Docker Compose file? If somebody's already been using Docker Compose, what's their path from Docker Compose into AWS Copilot?
So right now, there is no way for you to be able to import a Docker Compose file, but instead, in Docker Compose, you define individual services. You can still do that with Copilot. You would be running one by one for each one of the services that are available. If you're curious, you can alternatively check out the Docker ECS integration that was recently announced. Those will be the two paths that you could use with going from Docker Compose to ECS.
Yeah, that makes sense. So we've been talking about Copilot a lot. I understand you have a demo you'd like to show us. I always like to get hands-on and actually see this code running, see some video of the terminal going. And
let's do it.
Let's see what Copilot looks like.
Yeah, let's do it. Okay, so I think I should need to share my screen. Hello, can you hear me?
Yeah, you should be able to share your screen.
Okay, somehow my screen froze, but.
Uh-oh.
Okay.
All right, there we go.
Okay, am I good? Can everyone see me? See the terminal and everything? Okay, perfect. Okay.
We can all see the terminal now.
Okay, perfect. So I'll be giving an overview of how you would go by, using Copilot to deploy and manage a containerized application on Amazon ECS and AWS Fargate. Over here, I have a sample Git repository named Vote app. I ran 3, so we can see all the files that's in my repo. Just for this demo, I have a very simple application with 3 microservices. Right? I have an admin microservice. You can see from the Docker file. It just renders an HTML page. I have an API microservice as well as site microservice. I've already run Copilot in it for each one of those. So I've deployed these services already with Copilot. And once you deploy everything, at the end, you'll see this Copilot directory. Don't worry, we're going to take every single step that I've done for this again. I'm just showing you the end result right now. So for example, under Copilot, you'll see 3 different directories for each one of your services with a manifest file under them. And I'll give an explanation of what that is. And I've already set up continuous delivery pipeline for my application. And you can tell that by the pipeline.yaml file that's in here. Now, from the root of my repo, I'm going to type Copilot to see the help menu for the CLI. And you can tell that it's telling me that it helps me launch and manage applications on Amazon ECS and AWS Fargate. That's exactly what I want. We have a bunch of commands in the CLI, which are under different categories. For example,
I love how well this is organized and documented. It's very clear to me right away. I can see that I get started, I develop, I've released, and I just kind of go through the flow from the top down to get my application running.
Yeah, and I love the little emojis over here. That's my favorite piece. So right now, like you were saying, we have a getting started category. That's if I'm brand new and I want to start an ECS application. The develop commands, you could use them to do both like evolving your application by adding additional microservices, or you can do some operational commands such as service log or service status here. Finally, we have 2 different options for releasing your services, right? I can set up a continuous delivery pipeline, or I can do a manual deployment. And I can associate my services with additional AWS infrastructure with the add-ons commands. So for example, I can add an Amazon DynamoDB table, or I can add an S3 bucket to my service. So what I'm going to do from here now is get started with Copilot. So I'm going to type Copilot in it. And the first thing that the CLI does, it welcomes me. It tells me that it's going to ask me a bunch of questions to help me started with an application on ECS. And then an application is just a collection of my containerized services that operate together. Since I already run Copilot before in this Git repository, it detected that I've created an application named Vote app. The first question that it asked me is which type of service best represents your services architecture? And this is exactly what we're talking about earlier with Nathan about our first tenet being users think in terms of architecture and not of infrastructure. If I type question mark here, it tells me that a load balance web service is a public internet-facing HTTP server that's behind a load balancer. So this will be the architecture that I would use if I want a service that's accepting requests from the internet. Then I have a second option here that says a backend service is a private non-internet facing service. This will be the option that I would use if I want a database, a service that's talking to a database that no one else from the internet would be able to access. So I'm gonna choose a load balance web service for demo. I'm gonna name my service vote site. And then the next input is the Docker file, right? So in my repository earlier, I showed that we had 3 different Docker files, each one for our microservices. So the CLI recognized the location of the Docker file, and then it prompted us which one we want to use for this microservice. In this situation, I want to use site Docker file, and this will help us build the container image and then have that container up and running on Amazon ECS and Fargate. Looks like it created the infrastructure needed for the application. It says that it wrote something called the manifest file at this particular location. So we're going to take a look into that next. It created the ECR repositories. We're all good for local development. Next step is to deploy this. So we actually have our service up and running. So I'm going to say yes to this. And while the deployment is happening, I'm going to switch over to my next step so we can view what this manifest is all about. So let's take a look at what that looks like. I just opened up the file. So for each one of my microservices would get its own manifest file. And the manifest file is really our architecture as code, right? So this is our abstraction on top of CloudFormation that would provide you the most common knobs, the most common configuration that you might need for a load balance web service. For example, we have the location of the Docker file, we have which port is exposed, and Copilot will parse your Docker file to be able to detect if you have specific instructions, such as an expose instruction for your port, or if you have a health check instruction, and will automatically fill those values in the manifest for you.
Can I just interrupt for a second and say that this manifest is amazing. Like when I look at this, I've seen a lot of application configurations, over the years, and a lot of them, they get really complicated. You have, these JSON, these files that have all the semicolons, quotes, and all that stuff. And what I'm seeing here is it has documented comments in there explaining what everything is. And just the settings themselves are very simple. I see like CPU, memory count, stuff that I can kind of understand. And with the explanations there, like this looks like a way simpler way for me to configure my application without having to learn a lot of like basically magic keywords and magic settings that are in some really complex configuration format.
Yeah, exactly. We try to really instill the essence of what a load balance web service might look like. So you have your container settings with CPU and memory. You have your count, which is just the number of tasks that you might be running for your service. And here are the configuration for your load balancer. This is the path that the load balancer should listen on and forward requests to your service, or you can set up a health check setting from the load balancer. We have some more advanced configuration at the bottom, so you can inject environment variables, or if you have any secret that is stored on AWS Systems Manager parameter store, you can inject them also as environment variables to your service. At the bottom, we have some environment overrides. So any of the values that you see over here, you can override them per environment. So you can imagine in this situation, we create everything with minimal settings, so it doesn't cost too much. But we can imagine that a production environment, you want your service to be reliable. So instead of a count of 1, you could set, hey, for prod, set a count of 3. So my service is reliable. Okay, so I'm gonna exit the manifest. That's what the manifest does. You can modify this and then do another deployment, or you could just commit this change and then do a git push if you have a pipeline set up, and that will trigger, you will automatically increase the count of your of the task in your service to 3, for example. If I go back to the CLI, you can see that it says that, okay, environment test already exists in my application Vote app. That's because I've already run this command before, and it created all this networking infrastructure, like the VPC, the ECS cluster, the ECR repositories. So Copilot handles that for me. And then the next step that it started doing is that it built the container image from the location of my of the Docker file. And then it pushed that onto ECR. It says that it pushed it, and now it's deploying the service itself. So while the deployment is happening, I'm going to put my operator hat on. I'm going to switch from being like a builder, right? And I want to see the status of my service. So I can type Copilot service, and underneath it, I can see that there is a show and status command these seem relevant to me. So I'm going to type Copilot service status. And the first thing that the CLI will prompt me is, okay, which service and environment combination you want to show, right? So I've already deployed my 3 microservices to 2 different deployment environments, a test environment as well as a production environment. And I want to choose to visualize the service status for my both sites service in a test environment. So I'm going to choose this option, and boom, it tells me that, okay, looks like the deployment is over. Actually, I have one task that's running. Everything is good to go. Last deployment was in a minute ago. The status is running. And if you have any alarms set up already for the service, in this situation, I had set some alarms up. You can see the alarms and the status of your alarms through Copilot service status. So since the deployment is almost over, that means that the spinner should also go away pretty soon. But just to show that we really don't have any magic with the CLI, every single step that Copilot takes, every single infrastructure is provisioned through CloudFormation. So for example, this would be the stack for my vote sites service that's in the vote app application in the test environment. And you can see all the resources that we create for you that you don't have to worry about, such as service discovery for private communication, setting up all this networking configuration between the load balancer and your ECS service. We should see the log group, the ECS service itself, the task definition, as well as permissions with your task role, right? You don't have to worry about any of those. And I just saw earlier before switching to CloudFormation that the deployment is done, and even tells me at the end, okay, this is where you can access your service. It gives us the URL. So I'm gonna quickly copy this, go back to my browser, paste, boom. It says, hello from the vote site service. The service is up and running.
So this is live, right? What happens if everybody in chat gets this URL?
Go for it. We have only one task running with minimal CPU and memory, so please be gentle.
But how would I go about scaling it up if I did want to handle all 2,000 plus people in chat accessing this website at once? I would do that through that manifest file, right?
Exactly. So let's do that. So just like to demo how that would look like, I would go to vote site, the manifest, and I would say, okay, in this situation, maybe I want 1024, then I want to count to 3. And that should definitely be enough for everybody in chat to be able to handle that. And I could do, let me type Copilot again to see the help menu. And for releasing, we had 2 different options. I could do Copilot deploy to do a manual deployment, for example, right? So let me type Copilot deploy. I'll take vote site again. I'll say, okay, now deploy with my new manifest to the test environment, and it will start the deployment. I'm just not going to do that for now, so we don't have to wait for another deployment to happen.
Yeah, that's fine.
But
that's fine.
I'll show some other commands that are available. Yeah,
I can see how that's very easy though. If I was in a situation where I was running a website and I was getting more traffic than I expected, it's very easy for me to just change these settings and run Copilot deploy again. And I'm scaled up now. I can handle 1,000 people hitting my website if I needed to handle that.
Yeah, exactly. And if you forget any of the settings that Copilot showed earlier, such as the URL of your service, right? I can type Copilot service show, and then I'll choose my service, and that will give me my configuration, right? So it will say, okay, right now you have, so the vote site service is a load balance web service. It's deployed in 2 different environments. Both have the exact same configuration here with minimal configurations. These are the routes that you can access the service. So the load balancer endpoints, and you can tell that we have 2 different load balancer, each one for a different environment. The test environment gets its own load balancer, and our production environment gets its own load balancer. We set up service discovery by default for you so that the service can be accessed privately through other services in your application. And we inject some of the environment variables that you might find useful, such as the DNS name for the load balancer, as well as the service discovery endpoint, so you can start leveraging this namespace from your application code. So what I'm going to do now is show some of the commands that's available to us to evolve our application, right? If I want to add a new service to Vote app, I can run Let me show Copilot service again. I can do Copilot service init. And in this situation, let's say I want to add an API that's communicating with a database. So I will choose a backend service. I'll name this boot API and pick my Docker file again. Oops, I picked the wrong one. It's okay, it doesn't matter. So, and then it will create the necessary infrastructure here. So it will say that, okay, the manifest is ready, you're good to go. If you want to deploy it, just run Copilot deploy. And that's all you need to do. If you want to create a new deployment environment, right now we have both test and prod PDX. I can type Copilot env, and that tells me that these commands are for environments, and then environments are deployment stages that are shared between services. So I can type Copilot env init, and I can say, for example, I want prod IAD, and then I choose which name profile I want to use for my new deployment environment. So with this, I can choose, for example, prod, and that will deploy to a different AWS account as well as a different region. And then you will get a new deployment stage available to you. Now, with Nathan, we showed earlier how we can do Copilot deploy to manually deploy our change. But another command that was available to us was Copilot pipeline. So this is how I would set up my continuous delivery pipeline and satisfy our third design tenet of the CLI. So if I go to Copilot pipeline to see which commands are available for me, I can initialize a new one, I can update my pipeline, delete it, see the status of my pipeline, show some configuration settings of my pipeline. And let's show how we would set up a new pipeline. So I would type Copilot pipeline in it. And then you choose the order of deployment for your environment. So I'm going to say, I want to first deploy to a test environment. Then I want to deploy to production. This is the location of my GitHub repository. So the CLI detected that. And then it asks me for the personal access token to access this repository so that the pipeline can pull the code changes and then deploy them. I'm going to quickly copy my access token, paste.
I just want to say good job with not accidentally leaking your GitHub token to Twitch.
Yeah, it was practice. And but if we take a look at the pipeline file, you can see that it's a very minimal configuration that you would need for a continuous delivery pipeline. It says that the source is a GitHub repository. This is the name of the repository. This is the branch that we should be using for doing our releases. And these are the order of our deployment environments. First, we're going to deploy to test and then to production. And if we do pipeline update from here, let me show quickly how the end result looks like. So I'll switch over to the code pipeline tab. Let me go under pipelines. And this would be the pipeline that gets generated. So the first stage is going to be the source stage that's just going to pull the changes from your GitHub repository. Then in the build stage, we're going to build each one of the container images for each one of your microservices. So for admin, for API, as well as for the site microservice. Then we're going to start our deployment. So first to the test environment, and then to the production environment. Each one of them will create a different CloudFormation stack for your microservices. And you don't have to go to the console to be able to visualize the status of your pipeline. You can always stay within your terminal. You just type Copilot pipeline status, and you get to see what the pipeline looks like. This transition I enabled. My previous deployment was successful. So, just to recap, right? We've seen how to get started with the CLI, with the Copilot, getting started commands. We saw how to operate with the Copilot service status command, service show. I didn't show Copilot service logs, so we can do that really quick. Oops, typo. And I can choose, the vote site service in the test environment, and that will start displaying your logs. So that will be the operational commands that are available to us. We show how we can set up a continuous delivery pipeline by using Copilot env init as well as Copilot pipeline init. That's roughly what I had for the demo.
That's amazing. I just want to say this is a full toolkit. This is a toolkit that probably a large company, they would probably build from scratch, perhaps in order to be able to operate with multiple services. And here, I don't have to build this from scratch. It's already there. It's already released. It's maintained by Amazon and AWS. Obviously, I see there's a lot of issues on there. Clearly, I imagine the team is probably looking for suggestions and things to work on from those issues.
Yeah.
That's awesome.
Yeah. So, go ahead. Sorry.
I was going to ask, what can you say about what's next? What's coming down the line for Copilot?
Great question. So, we had many requests for being able to, instead of us creating a VPC and all this like networking configurations, such as the subnets, the CIDR ranges in your VPC, people have already existing VPCs, and they just want to use that with Copilot. So we're actively working on that right now. So if you go to issues, issue number 740 is request. You can expect minimal patterns to be added to the CLI, right? Right now we have 2 patterns that are available, the load balance web service pattern, as well as the backend service pattern. We're working on adding a scheduled service pattern so that, on a daily basis, a scheduled task is triggered or something like that. And then, we would love to hear from you for what more we can do in the operational space. So what would you be looking for besides log and being able to see the status of your service?
Yeah, if moderators haven't already, I see that. Drop a link into the chat for this GitHub repost. That way everybody can go check it out. I see we got a few more stars on the repo just during this session, so it's exciting to see more people checking it out. And feel free to test it out and leave a comment in the issues if you run into anything that you'd like to see us improve. We're always looking for more stuff to work on, obviously. That's very cool.
Yeah. And this is the link to our documentation if you go to the README, and we have installation. We have also instructions on how to install the CLI under the installing section.
So we're just installing with Brew. Okay, so it's very, very easy to get started with installing Copilot on your own development machine, and encourage you to do so and check it out. Is there anything else that you want to tell the audience, or any questions we can? I see one question from the audience. Will Copilot support PowerShell? I imagine that's asking about Windows environment then. So it's actually a question I have seen a couple times from people asking, will Copilot support Windows?
Yeah, so we have a Windows binary right now in our, if you go to the releases for the CLI, but our current recommendation is that would prefer if you would use the Linux or the macOS binary. We have heavily tested both of these binaries. So if you can use the Linux subsystem for Windows and then install the Linux binary, that would be the preferred route.
Yeah, that makes sense. That makes sense. Cool. Well, thanks a lot for showing us this demo.
And thanks for joining.
Yeah, I'm excited about Copilot and seeing where it goes and what kind of applications people develop with it. Where can the audience reach out to chat with you more afterward if they have more questions?
Yeah, so we are super active on, in the Copilot repository. So if you cut us an issue, we'll get back to you very quickly. Alternatively, we also have in the README, you can see that there's a chat button over here. So you can also chat with us live on Gitter.
Oh, that's perfect. Yeah, people will be able to ask questions live to the team if they have any questions about Copilot. That's fantastic.
Mm-hmm.
Well, thanks a lot for doing this demo and talking about Copilot. And
thanks, Nathan.
We'll move on to the next segment.